Alright, so this is the second video on modeling quadratics. Make sure if you haven't watched the other one that you watch that one as well. Both are kind of very typical quadratic modeling problems. So what this one says, it says the perimeter of a rectangle is 400 feet. Let x represent the width of the rectangle. Write a quadratic equation to model the area of all rectangles with a perimeter of 400 feet. Then find the dimensions of the rectangle with the biggest area. Okay, so a really common application piece is you go out and you want to build a fence for your dog. Okay? So you buy 400 feet of fence, and then you have to decide, what's my width and what's my length so that the dog has as much area to play in and run around in as possible. Okay? So that's really what we're going to look at here. So in order to do that, I first need to know a couple of formulas. I need to know the perimeter of a rectangle and the area of the rectangle. Okay? So the perimeter of a rectangle, if I draw one out, it's said to let x be the width, right? So the x is going to be my width, and then I'll let y be my height for right now. Okay? And so then when I know in a perimeter is distance around, so I'd have x and y, and then x and y, or I'd have 2x plus 2y. So what I know right now is I know 2x plus 2y equals my perimeter. In this case, my perimeter is 400. Okay, so I can come back here and let's make this specific 400 feet. Okay? All right. Next thing it says, I want to find a formula for the area of a rectangle. Area is length times width. So the area is going to be, x times y. All right. My problem with this equation is it actually has three variables: area, length, and width. It's got three variables in it. When I write an equation to be able to solve, I need it to be just in two, x and y. Okay? Or in this case, probably a and x. Okay? So what I have actually up here is I've got a second equation I'm actually going to be able to use. Okay? What I want to do is I want to figure out what y is and turn that into just x's. Okay? So what I'm going to do is I'm going to take this perimeter equation, 2x plus 2y equals 400, and I'm going to solve that for y. And then I'm going to substitute that equation into y. Okay, so we're going to do a little work over here. I'm going to take 2x plus 2y equals 400. I'm going to solve for y, so I'm going to subtract 2x. So I get 2y equals 400 minus 2x, they're not like terms, then divide by 2. When I divide by 2, I have to divide everything by 2. So in the end, I get y equals 400 divided by 2 is 200, and 2x divided by 2 is just x. Okay? So the y value is going to be 200 minus the x value. So what I can do then is I can take this 200 minus x and substitute that into my area equation. So area equals x times y, length times width, so area is also x times 200 minus x. Remember, when we substitute something in, always put it in parentheses. So I get area equals x times 200 minus x. Okay? All right, so there's my area formula. The question then says, find the dimensions of the rectangle with the biggest area. So I want my area to be as large as possible. Okay? Well, I've got this quadratic that models it. And if I multiply this out quickly, I can kind of see something that happens. A equals x times 200 is 200x. And then x times negative x is negative x squared. So this negative x squared tells me that my parabola is going to open down. Okay? What that means then is I'm going to have a maximum, which is exactly what this question is asking me. I want to find the dimensions, the length and the width, okay, which in our problem stood for x and y, that end up giving me the largest area. Okay? So I'm trying to maximize the area. So really what I want to do is I want to find the vertex of this equation. Okay? So that's what I'm going to do. I'm going to find the vertex. Well, remember to find the vertex. For x, we take x equals the opposite of b over 2a. So in this case, b is 200. The b is the coefficient on the x term, so b is 200. So I get the opposite of 200 over 2 times a, and a is negative 1. That's the coefficient on the x squared. So 2 times negative 1. That's negative 200 divided by negative 2, or 100. Okay? All right, so what does that tell me? It tells me that the maximum area for a 400 perimeter rectangle would have an x value, or a width, of 100 meters. Okay? So that's one of my dimensions. Now I have to find the other dimension. And the other dimension is going to be my length. Well, if you remember a minute ago we had the equation y equals 200 minus x. So now I can just take that 100 and substitute it in for x. So I get y equals 200 minus 100, or y equals 100 meters. Now some of you might have been thinking about this logically at the beginning. If I want a rectangle that's got the most area, make it a square. Okay? And that's what just happened. We have 100 meters by 100 meters, so we have a square. So 100, 100, 100, 100. There's your 400 perimeter, and 100 times 100 is going to be 10,000. Okay, so that's going to be your biggest, area. Okay, 100 times 100, move the decimal over 2 spots. Okay, so again, let's finish this story off. The dimensions that maximize or maximize the area of my rectangle are 100 meters by 100 meters. Okay, so again, kind of put that in context. The dimensions that maximize the area of my rectangle are 100 meters by 100 meters. So basically, if you have a rectangle and you want to maximize its area, build a square. All right, so again, a very, very common type of problem for modeling a quadratic. Again, maximizing and minimizing really just means to find the vertex. In this case, I just wanted to find the dimensions, which was the x. Again, if I wanted to find the maximum area, I'd have to plug my x and y back into the area. So again, make sure you read the question. Is the question asking you for the dimensions in this case, or is it asking you for what the maximum area is? Then 100 by 100 wouldn't get the answer. Okay, I would need to actually put them into the equation and get that 10,000 square meters as my answer.